So all the word problems are will be on the calculator portion of the test. When you do these interest word problems, I always suggest that you just start with writing all the letters in the formulas. APRNT. So you invest $400, that's principal. 5% interest, that's your rate. Compounded continuously, that tells you N, but it's continuous, which all that means is we're using the PE-RT formula. So how long will it take? That's what we're solving for the balance to reach 600. That's A. So plug it into the formula. A equals P. Since it's continuous, that's PE to the RT. So plug in A, that's 600. Plug in P, that's 400. E to the 0.05 T, and solve for T. So divide by 400 first. That's 6 over 4, which is 3 over 2. Then, to get the variable down from the exponent, we're going to log it. Since it's E, it's natural log of 3/2 equals, now the exponent's chopped down, 0.05 T. And finish by dividing by 0.05. So on your calculator, we'll type in natural log of 3 over 2 divided by 0.05. Natural log, make sure you do parentheses for 3 over 2. And divide by 0.05. So we get 8.11. T equals 8.11. That's how long it will take for the balance to reach $600. 8.11 years. If you wanted to convert that to years and months instead of a decimal, it's pretty easy. You subtract the whole number, so subtract 8. So you're just left with the decimal. And then multiply by 12, because there's 12 months in a year. And you get 1.3 months, so a little bit over a month. If you had to, but on this test, you should see, I think everything's written as a decimal we use. So bacteria growth questions are the similar formula to the Apert equation. It's the N equals N naught E to the KT. So it's very similar to the principal. It's the starting amount and the ending amount. K is the growth constant. So for part A, that's what we're going to be solving for, is the growth constant. At the start, there's 6,000, so that's N naught. That's the start. Two hours later, so T is 2, there's 6,200. So we're going to solve this. We're going to divide by 6,000. The zeros cancel. 62 over 60 can reduce to 31 over 30. Since the variable's in the exponent, we log it to chop it down. So we natural log, because base E is natural log, 31 over 30 equals 2K. And to solve for K, we'll just divide by 2. So natural log of 31 over 30 divided by 2. Make sure you put parentheses around your fraction in the log. And then divide by 2. And we're going to store that as k because there's a lot more parts to this problem. So we'll store alpha k. So that way, whenever we talk about the growth constant, we can just type it in. We don't need to type all those decimal points. But the growth constant, for writing it down, let's round it, 0.0164. K equals 0.0164. We have the more accurate answer saved in the calculator, but writing it down, that's good. So we'll write out the equation. N equals N naught, which was 6,000. E to the 0.0164 T. There's our equation. Just plug in K and leave N and T as letters. So how much bacteria will there be after 8 hours? We're going to plug in 8. We have 6,000 times e to the 8k. So the 0.0164 whatever times 8. That's in our exponent for e. So in our calculator, we do e to the 8 times k. Make sure you put the 8 times k inside parentheses. So we did e to the 8k, now multiply by 6,000. And that's 6,840.9. So since it doesn't really make sense to say that we have 0.9 bacteria, let's go ahead and round that to 641, 6841. And then part D, how long will it take for the population to reach 10,000? So that's our N, 10,000 equals 6,000 e to the KT. We're solving for T. So the first step's got to be divide. So 10 over 6 reduces to 5/3. Since the variable t is up in the exponent, we're going to log it to chop it down. So change it to natural log of 5/3 equals kt. And we're solving for t, so we're going to divide by k, which is the variable we have saved in our calculator. So natural log 5/3 divided by k. Natural log parentheses 5 divided by 3 divided by k. 31.158. That's time, and time, looking around at the problem, all the time measurements were hours. So that's 31.158 hours. Similar to when we converted the decimal to months, we could do the same thing here. You subtract the whole number. And then since it's talking about hours, if we want to figure out minutes, since there's 60 minutes in an hour, you just multiply by 60. And you'd find that that's about 9.5 minutes, if you needed minutes to go with the problem. So that'd be like 31 hours, 9.5 minutes. But decimal should be fine for right now.